Excellent. So we're in chapter 24. And now, instead of taking the derivative of something, we're going to take the integral of something, which is the exact opposite of doing it. So the integral of y prime is going to be y. So it's the inverse. The antiderivative. Antiderivative is sometimes called the integral as well. If I had y is equal to mx plus b, and I took the derivative of y, I would get m, right? If I took the integral of y prime, I get y back. I would expect mx plus b to come back, right? How do I get the b back? How do I know that that was a 3 and not a 4, or a 5 and not a 6, or a 7 and not an 8? I don't. So when we end up taking that the integral back, we end up adding a constant of integration. And then if we have some limits to our integration, we do this from 1 to 0, then that constant of integration will go away, or we have to know an initial condition to find that constant of integration. Otherwise, it'll just have to be there. So we have rules. The rules are on page 792. So if I take the integral of du, I'm going to have u plus some constant of integration. If I take the derivative of some constant du, then I'm going to have some ku plus some constant of integration. Because the integral thing is linear, I can bring the k on the outside, and that is the same as what I had up there, except now I got a k in front of it. Now, the question is, if I have k integral du, don't I have k times u plus c? Yes, I do, and when I multiply that out, I get this. Now, how is that possible? Why don't I have kc? Why is that? Well, the constant of integration is some arbitrary thing. It's still just as arbitrary if I multiply it times a c, so by a k, so the k goes away. So the constant of integration is something we play fast and loose with until I have an initial condition. I don't know what it is, so it doesn't matter that I multiply it by k or not. So I go from here to here, perfectly okay. Oh, we love that, don't we? Oh, yes. Yes, love that.
Is that exception only for
integrals? Yeah. Yeah, so if I had 2 times a plus b, I wouldn't go 2a plus b, would I?
No.
No, because no, I wouldn't do that. So I can't do that. But here, I do that all the time.
Well, yeah, I knew the example you gave me, but I didn't know.
No, it doesn't go backwards, no. If I have the integral of f of t plus g of t dt, if I have something like that, then that's just going to be the integral of the first guy plus the integral of the second guy. Multiplication doesn't work that way, so we don't have a rule to do that. Okay, those are our rules. Now we're going to have to do number 1 through 23. You want me to just do the even ones or do them all? Do them all? Okay. Integral x to the 7th. Well, we forgot one rule. Bummer. How did we forget the rule? If we have the integral of u to the n du, then we're going to have u to the n plus 1 divided by n plus 1. Because if I take the derivative of u to the n plus 1 over n plus 1, I end up with n plus 1 times u to the n divided by n plus 1, and that ends up getting back to what I got, right? So I end up, when I take the integral of something to the n, I add 1 to the exponent, and then I divide by that new exponent. Okay, back to number 1. X to the 8th divided by 8th plus some constant of integration c. Number 2, x to the 24th.
Wait a minute,
X to the 25th. What didn't follow? Divided by 25 plus c.
Explain how you got that.
I added 1 to the 24 to get a 25. I divided by the 25, and then I said plus c because I have to have a constant integration. Because the rule says I add 1 to it and divide by the exponent.
Okay, thank you.
That's what the rule says. Now, if you think about it, and you think about if I have y is equal to x to the 25 divided by 25 plus c, and I take its derivative, what am I going to get? I'm going to get 25 x to the 25 divided by 25. Those guys go away. I got x to the 25, which is how I check my work. I don't know if I did it right.
Why is it x to the...
I have no idea.
Never mind.
I have no clue.
The reason why it's
Four,
x to the
four.
24th and now it's 25th is because the rule is to n plus 1.
Yeah, exactly. That's the rule. Plus 1. Number 3. The integral of 3x to the 8th. Alright, so I'm going to have 3x to the 9th divided by 9 plus some constant of integration. I'm going to have x to the 9th over 3 plus c. Yeah, because I'm going to simplify my work, I'm not going to leave it as a piece of meat thing. Integral of 200 x to the 9th. So I'm going to have 200 x to the 10th divided by 10 plus c. And I'm going to simplify that in 20 x to the 10th plus c. Number 5, integral 4 dx, 4x plus c. Number 6, integral 8x to the 3 halves dx, 8x to the 5 halves divided by 5 halves plus c. 16x to the 5 halves over 5 plus c. That'd be my final answer. See, we're just getting, we're just practicing multiplying, dividing, right? Multiplying, dividing fractions. We're calling it taking an integral, but really we're just trying to do 8th grade math again, right? Until we get it right. How many more years before you get it right, anyway? Number 7. I have the integral of 9x to the 5 over 6 dx. I'd never leave it in the form that the book has it. Integral, get rid of the integral sign.
How did you get into that?
Well, what does that mean? What does the 6th root of x to the 5th mean? It means x to the 5/6. I think that was chapter 10. Alright, so I got 9 x to the 11/6 divided by 11/6 plus c. I added 1 to 5/6. 1 plus 5/6 equals 11/6.
So adding 1 is adding 6 over 6. Okay.
Let's see, now I back to what 6 times 5 is. That's 54 x to the 11th 6th root of divided by 11 plus c. So I could do that, or I could leave it as a fractional exponent, whichever one I decided to do.
Is that because
8.
when you are dividing by a fraction, you multiply by the reciprocal?
The other things. Right, number 8. Did I answer your question, William, or did I
Like
ignore you?
When you have, like for example, this one was the 9x 11
Yeah.
over 6 divided by 11 over 6.
Yeah.
So then it would be the same as saying 9x 11/16 times 6 over 11. Multiplied by the reciprocal.
Oh yeah, I'm multiplying this by the reciprocal, right?
Right.
I'm inverting and multiplying.
Right.
Right. Okay. So I have 9 divided by 11 over 6. I invert and multiply. 9 times 6 over 11 equals 54 over 11. Is that what you're trying to tell me? Okay. I thought you were trying to ask something more profound. I should have known better. All right, so I got integral 3x to the minus 2 dx. Yeah, I wouldn't leave it in the form it is because I don't have a way to solve it in the form it is, right? But in this form I can solve it. 3x to the minus 1 divided by minus 1. Minus 3 over x. Now, plus c. Now, I can always check my work. So if y is minus 3x to the minus 1 plus c, then y prime would be the minus 1 goes out in front, making it positive, x to the minus 2, which is 3 over x squared, which is in fact what I was taking the integral of to begin with, so everything's fine. So I can always go back and check my work if I wanted to check my work. Number 9. Integral 6 dx over x cubed. I say, well, I don't like that. Integral 6x to the minus 3 dx. 6. I add 1 to get a minus 2. I divide by minus 2 plus c. Minus 3 over x squared plus c, and I'm done.
How did you get that?
Get where?
How did you get the 3 over x squared?
2 goes into 6 3 times. My 9th grade algebra teacher did not want me to have a negative exponent, so I put it in the bottom so I could have a positive exponent. Good enough? Number 11. Integral dx, the 6th root of x to the 5th. All right, well, I change that to x to the minus 5.
No, this is 10.
No, it doesn't. It says 10. Where were you? Not paying attention again? All right, so I would have x. I'm going to add 1, so that'd be 1/6 divided by 1/6 plus c. So my final answer would be 6, the 6th root of x plus c. Number 12. Nope, number 11. Someone's got me all messed up here already. I don't believe it. Okay, so I got the integral 5x squared minus 12x plus 8 dx. Alright, so I'm going to take 5x cubed over 3 minus 12x squared over 2 plus 8x over 1 plus c. And then I'm going to rewrite it and call it 5/3 x cubed minus 6x squared plus 8x plus c. And now I'm perfectly okay with that. Do it again. Number 12. Integral 7x to the 10th 8x to the 4th minus 11x cubed dx. Sometimes those parentheses we don't put in, they're implied because there's an integral sign at the beginning and a dx at the end, but I put them in anyway, equals 7x to the 11th over 11 plus 8x5 over 5 minus 11x to the 4th over 4. There's nothing I can do about it. Plus c, constant of integration. I'm done. I'm only using one line. How could this get any easier than this? I mean, well, I could, you know, I guess I could make it easier. 13 integral 3x squared minus x plus 5x to the minus 3. And so I'm going to have x cubed minus x squared over 2 minus 5 over 2x to the minus 2 plus c. Guess I'll have to rewrite that. X cubed minus a half x squared minus 5 halves, 5 over 2x squared plus c. Alright, there we go. Now, not even getting interesting yet. Number 14. I think they get interesting around 15. Integral 2x cubed. Did I already do this one? Plus 3x minus 5x to the minus 4th dx. Sorry about that. X to the 4th over 2 plus 3 over 2x squared plus x to the minus 5 plus c. Oh gee, if I just rewritten this guy right, I wouldn't have to rewrite it, right? 1 over x to the 5th. Oh, okay. Number 15. Going fast enough, or need to speed up some here? Integral 2x squared minus 3 squared dx. Okay, two ways to do this problem. Well, you want to see them both, or you just want to see, okay, well, the most intuitive would be to say that this is the integral of 4x to the 4th minus 12x squared plus 9 dx. And then to say that this is going to be let's see, 4 over 5x to the 5th minus 4x cubed plus 9x plus c. There. Did I skip enough steps?
How did you get the 4x cubed?
Well, I had minus 12x cubed divided by 3, and 3 goes into 12 4 times, so I put down a 4.
Why didn't you just make it minus 12x to the 3rd over? You skipped a step.
Why would I want to do that? I could see it coming, so I saw it coming, and I put a minus 4 there.
Why didn't you just leave it at that?
Well, because that would, if I put minus 12x cubed over 3 like that, I still have to divide out that and put a 4 there, right? I couldn't leave it that way. So why would I want to write it down if I can't leave it that way? I'm always thinking at least 2 or 3 steps ahead. At least, right?
Yeah.
Sometimes more. See, is there another good way to do that one? I don't know. Let's say number 15. Integral 2x squared minus 3 squared dx. Okay, so I'm gonna guess. I'm going to guess that I'm going to be in the form 2x squared minus 3 cubed. And if I take the... Alright, now, so the derivative would be 3, 2x squared minus 3 squared times 4x. Now, I'm going to put them together. Times 4x. Well, that doesn't look like that. Alright. So, because I'm missing something. Yeah, I think the other way is more intuitive. We'll just forget about this altogether. Number 16. Well, we'll have to figure it out sometime.
We will?
Well, yeah, in another chapter probably. X squared minus 5 squared dx. Alright, so integral x to the 4th minus 10x squared plus 25 x to the 5th over 5 minus 10 over 3x cubed plus 25x plus c. What? Who? Where? Can't keep up? Integral square root of 6x plus 2. Okay. So we're going to guess. Where's my guess? We're going to guess that we're going to be in the form 6x plus 2 to the 3 halves. Okay, so I'm going to take the derivative of that, and it's going to be 3 halves 6x plus 2 to the 1 half times 6x. So g prime would be 9 square root of 6x plus 2. And I don't have a 9 here, so I'm going to put a 9 there, and then I'm going to put a 1/9 out there.
How do you just add stuff into the equation?
What did I just multiply by? 1. Aren't I allowed to multiply by 1? Anytime I damn well please. Can I multiply by 1?
No.
Yes. Anytime.
You have to keep the equation the
But
same.
this requires me, this allows me to find the answer, because now the answer is this times a 9th. So now I can write down the answer. 1/9 times the square root of 6x plus 2 cubed plus c. And then we could rewrite that as 1/9 6x plus 2 to the 3 halves plus c. This is a time when I'm just, the 1/9 is just being sucked into the c, so to speak. And that would be my final answer. But I would guess what it is. I'd guess the form. The form has to be to the 3 halves because it's got to be up 1, right? And then I find out that I need a 9, so I put a 9 there, multiply by 1/9, and everything's fine.
Okay.
Yes, that's one way to look at it. Any other way you'd like to look at it?
Why is it to the 3 halves?
What's 1/2 plus 1? Yeah. So if I have the integral of x plus 2 raised to the 17/37ths, if I have that, then the form of that integral has to be one more than 17/37ths. So the form is going to have to be x plus 2 to the 54th 37ths, because I'm adding 1 to it. Yeah. All right. So that's what it has to be 2/3 because I added 1 to it. It's a form issue, not a substance issue. Okay, so I got integral third root of 8x minus 1 dx. I'm going to guess, and this is a guess, that the form has to be 8x minus 1 to the 4/3. Why 4/3? Because 1/3 plus 1 is 4/3. Y prime. 4/3 8x plus 1 to the 1/3 times 8. 32/3 cube root 8x minus 1. Even though it's not a minus there, it's obviously supposed to be a minus, so we'll put it back. Alright, so I need a 32/3 sitting right there. So I'll multiply the outside by 3/32. And then I'll write down my answer. My answer is going to be 3/32 8x minus 1 to the 4/3 plus c. But if I didn't make an educated guess what the form was and figure out that I needed a constant out in front, I couldn't have possibly have gotten the right answer. There's no other than putting in your TI-89 or 86 calculator and asking it what the answer is. You could do that because you have an integration thing in there. Number 19.
Yeah, but in calculus they don't.
How far do I go?
They don't let you use your calculator.
So, this is not calculus 1.
But if I want to take calculus 1, I have to be able to
Well, you better be able to do it then by then. Alright, 19. Integral 8x x squared plus 3 raised to the 3rd dx. Alright, so I'm going to guess. I'm going to be in the form x squared plus 3 to the 4th. In which case, g prime would be 4 x squared plus 3 cubed times 2x. Yeah, look at that. I got 8x, that whole thing. So my answer is x squared plus 3 raised to the 4th plus c. Already solved it.
How the hell did you get to that?
Well, I guessed the right answer. And because I guessed the right answer, I wrote it down.
Question.
The right answer has to be in the form x squared plus 3 to the 4th power. It has to be. Now I just lucked out, and I already have an 8x out in front, and I got an 8x sitting in front of this guy. Yes.
You take when you add the plus 1, why don't you add it to any of the exponents inside the parentheses?
Why would you want to? What does the rule say?
It says to add 1.
So it says the integral du is u x blah 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 blah. Yeah. So I don't have any rule that tells me to do that. It's the form that's on the inside. So that's just a u guy.
So the entire parentheses is u.
Yeah, basically. Yeah.
So that's why you don't add to the ones inside the u, just whatever
Yeah.
u itself is raised to.
Yeah. That's one way to look at it. There will be more complicated ways to look at it. The way we're going to look at it today is we're just going to do what the rules say and not worry about it. 20. Oh, wow. Integral 18x squared x cubed plus 2 to the 5th dx. Okay, so I'm going to guess that the answer has to be in the form x cubed plus 2 to the 6th. And if I take the derivative of that, I'm going to get 6 x squared plus 2 to the 5th times 3x squared, which again is exactly what I have here. So my answer will be x. I know where I'm going after the class. Okay, x squared plus 2 to the 6 plus c.
How'd you get to 3x squared?
Yeah.
Right here, 3x squared. It's right there. It's part of the problem.
No, that's a y.
Oh, right here. What's the derivative of the inside? 3x squared. Right. When I take the derivative of this, I put the 6 out in front. I subtract 1 from the 6 and make it a 5. And then I take the derivative of the inside and get 3x squared.
It just looked like that x there was like a 2 per second. X.
Oh, this, you mean that 2 here? This one here?
Yeah.
That 3 doesn't look much like a 3?
There we go.
Is that what you're complaining
That's
about?
what I got. That's what I was like, what?
Yeah.
I was confused for a
I
second.
mean, clearly the marker, there's a thing here on the side of my marker that if I touch, it obviously is not going to do what it's supposed to do, and I'll be hosed over. All right.
21.
Number 21, and then we get to go to the next section, or do we have to go to?
23.
We got to go to 23 yet. Okay, integral x, the cube root of 5x squared minus 1. Okay, so I'm going to guess that the answer is in the form 5x squared minus 1 to the 4/3. I'm going to take the derivative. I'm going to get 4/3. 5x squared minus 1 to the 1/3 times the derivative of the inside, 10x. Okay, so I need 40 over 3x times that guy. So I need a 40 over 3. I'm going to multiply it by 3 over 4 on the outside, and then I'm going to write down my final answer. Maybe I am. I don't know. Oh, I am. And I'm going to say I'm 3 over 40 times 5x squared minus 1 to the 4/3 plus c. Say again?
I said, by George, I think I got it.
Well, if I do it enough times,
Yeah.
that's the whole point. Number, that was 21? 22.
Should go back to that one. Follow that one. Absolutely. Too late.
I mean, it doesn't even get expanded past the screen. Alright, while we're looking at it, I'll fill in this 5x squared minus 1 to the 1/3 here, just to fill in the blank. I wasn't going to put that in because it wasn't necessary. I only needed to know what had to go on the outside. Anyway, I may continue. I have permission. Yay! Integral 3x square root of 6x squared plus 5 dx. I'm going to guess I'm going to be in the form 6x squared plus 5 to the 3 halves. G prime is going to be 3 halves 6x plus 5 to the 1/2 times 12x. So 2 goes into that, it's 18. So I need an 18. So I'm going to multiply by 6, and I'm going to divide by 6, and then I'm going to write down my final answer, 6x plus 5 to the 3 halves plus c. Right. Moving on to number 23. Integral x squared minus 1 to the 4th. Okay, so I'm going to guess I'm in the form x squared. I could, but then you'd ask me to add steps. 5 y prime. Yes, I can solve this without guessing. It is that easy. 5x squared minus 1 to the 4th times 2x. I need a 10 there. I need a 1/10 out there, which I knew already before I did the guess. All right. There, now you like that? 1/10 x squared minus 1 to the 5th plus c.
What do you do it without guessing?
I can, but that's only because I've been doing it for 18 years.
So you're saying it'd be more beneficial just to guess?
Well, you guess the right form. You guess the right form to figure out what you need to put in, how you need to manipulate the integral so you can solve it.
Not really a guess.
It's a yeah. It's a way you're calling it a guess. I'm putting it in green. I'm using a G. And sometimes it was the right guess, and sometimes I had to add something else. Yeah. So I'm not guessing in the form that you would guess. Like put down a 2. Yeah, I guess it's A.
2 plus A.
Yeah. Yeah. I guess the right answer is I have A, B, C, and D to choose from. It's because it's multiple choice. I choose E. Yeah. I'm a radical. I'm going to choose E. Huh?
You kind of deduce your answer.
Yeah. All right, so what's going on in the next section here? All right, in the next section, what we're doing is we're figuring out what the C is. Okay, so we're finding it's an improper integral. It has a C. There's a proper integral where we know what the C is. Okay, so now we got in section 24.2, we have to figure out what the C is. So we'll doing 1, 3, 9, 15, 19, 21. So that's probably all we're going to do. So number 1, we have y prime is equal to 3x, and y is equal to f of x, and y is equal to f of x passes through 0, 1. All right, so I'm going to integrate both sides and get y of x is equal to 3x squared over 2 plus c. When x is 1, when x is 0, y is 1. So when x is 0, y is 1, implying very strongly that c is equal to 1. So my final answer would be y of x is equal to 3x squared over 2 plus 1. Okay, looking at number 3. Number 3, I have some y that's some function of x, and I know that y prime is equal to 3x squared plus 3, and that this line up here passes through the point 1, 2, minus 1, 2. Okay, so I integrate both sides. I get that y of x is equal to x cubed plus 3x plus c. And I find that y at minus 1 is going to be 2, which is going to be minus 1 cubed plus 3 times minus 1 plus c. So 2 has to be minus 4 plus c, implying very strongly that c is equal to 6. So final answer, y of x equals, if I could see it, x cubed plus 3x plus 6.
So are we just going backward from the section prior?
No, you're solving for what the constant of integration is, knowing an initial condition. So I got an xy plane. I got that guy there. Y of x equals 5/7 x plus 100. Okay, I take the derivative of that, boom, and I get 5/7. Right. So now I got a problem. Y prime is seventh, and the answer to the problem passes through the point 0, 100. What is the equation of the line? Okay, I integrate both sides. I get y of x is equal to 5/7 x plus c. When x is 0, y is 100, c. So my final answer is going to be y is equal to 5/7 x plus 100. Okay, so that's all I'm doing. Number 9. Number nine. A stone is dropped from a height of 100 feet. 100 feet. There's my stone. It's dropped from a height of 100 feet. The acceleration is minus 32 feet per second squared. Find the distance the stone drops after 2 seconds. All right, so I want to find y of 2. Okay, so the derivative of velocity with respect to time has to equal acceleration. Okay, so dv has to equal minus 32 dt. I integrate both sides of the equation, and I find that the velocity at times t is equal to minus 32 t plus some constant of integration. Now, what was velocity at time 0? Well, I'm up here and I'm dropping it, so the velocity at time 0 is 0, which implies that c is equal to 0. So my equation is that the velocity at times t is equal to minus 32t, which is also equal to the change of distance change in time. So now I've got the change in distance is minus 32t, change in time. I integrate both sides of the equation. I get my position at times t is equal to minus 32 t squared over 2 plus some constant of integration again. What is my position at time 0? 100. So my position function is 100 minus 16 t squared. What is my position after 2 seconds? My position after 2 seconds is 100 minus 16 times 2 squared, also known as 64. So this would be 36 feet. Would it not be? Yes. 36 feet. Now in physics, you're doing the same thing, but you're given the equations you're working with, right? I don't have to memorize those equations because I know if I have constant acceleration, all I have to do is take the integral and I can find the velocity and do the other thing. I don't have to necessarily memorize equations for my physics class. Okay, that was number 9. Oh, wait a minute. Also find the velocity of the stone when it hits the ground. Okay, so now we come back up to our velocity equation. Now we come back up to our position equation. So our position is going to be, when it hits the ground, is going to be 0. So 0 is equal to 100 minus 16 t squared. So that means that t is equal to minus 100 divided by minus 16 square root, also known as 10 over 4, also known as 2.5 seconds. So I'm going to hit the ground at 2.5 seconds. My velocity at 2.5 seconds is going to be minus 32t t, right, minus 32 times 2.5, which is what? 128? No. 64 plus 16, 80? 80? Right. 80 feet per second, and it's going negative. The other answer could be it's 0. It hits the ground. It's not moving. Also find the velocity of the stone when it hits the ground. Okay, so at t, yeah, not after it hits the ground, but when it hits the ground. Boom. Yeah. Okay, so that's 9. So that's just another way to solve your regular physics problems. Number 15. I love that way. That is so wonderful. Because that way, constant doesn't have to, acceleration doesn't have to be constant. So,
Is that classical physics or is that general?
yeah. In general physics, yeah, in general physics, you cannot have anything but a constant acceleration. Yeah. In classical physics, the acceleration could be something else. So my acceleration might be 3t plus 2, for example. I could have a increasing acceleration. And I could solve it using those methods. But I could not solve that problem in general physics, where I only use algebra. Okay, back to number 15 before I run out of time again and have to start over. A stone is thrown vertically upward from the edge of a roof of a building 200 feet tall. Okay, so I got 200 feet, and I'm hanging off the side of the building, throwing the stone upward. All right, and so velocity at time 0 is 30 feet per second. Find the equation describing the altitude of the stone from the ground. Okay, so acceleration is minus 32 feet per second squared, okay, which is dv dt. So dv is minus 32 feet per second squared dt. I integrate both sides. Velocity at times t is minus 32t plus initial velocity 30, which is change in position, change in time. Change in position is minus 32t plus 30 dt. I integrate both sides. I get that my position at times t is minus 16t squared plus 30t plus my initial position, 200. And so I've done that. How does this take, how long does it take the rock to hit the ground? Okay, so when the rock hits the ground, rock hits ground, S of t is going to be 0. So 0 is equal to minus 16t squared plus 30t plus 200. Now I got a quadratic equation to solve. Everything's divisible by 2. So I can make this 8t squared minus 15t minus 100. Oh, can I factor that? Oh, bummer, probably not. T is equal to 15 plus or minus square root of 15 squared minus 4ac divided by 2a. Luckily, my calculator is all charged up, ready to go. 15 squared plus 4 times 8 times 100 equals square root. So I have 15 plus or minus 58.2 divided by 16. Oh, that doesn't seem right. Oh yeah, it does. That seems right. So t is equal to solution set. We'll take the so this is really 52.5. So we'll take the negative guy first. So at minus 2.7 seconds, and then we'll take the positive guy. .6 seconds. So I have 2 times. My math has given me 2 separate times. So the negative time is if I was down here throwing it up at negative time, I would have passed that point going upward with an initial velocity of 30 feet per second before I started going up and coming down, and I would have hit the ground at some time in the future at 4.6 seconds in the future. So the negative time is not from where I actually did it at time 0, 200 feet above the ground, but standing on the ground. Okay, enough of that. What's next? 19? Is there an electronics problem to do? I hope so. 21's the electronics problem. It's about 19. 19. Okay, good. 19. A capacitor has a capacitance. Isn't that lovely? Don't you just love it when they say some really cool thing like that? Capacitor having a capacitor. And it has a voltage of, okay, V across the capacitor, 100 volts. At a given instant, t is equal to 0, the capacitor is connected to a source. Okay, so I've got current is equal to 1/2 the square root of t plus 0.2 amps through the circuit. Find the voltage across the capacitor when t is equal to 0.16 seconds. Okay, so the voltage across the capacitor is Q over C, right? Yeah, Q over C, and I is dQ dt. Okay, so that's what I is. All right, so I got to come up with what Q is. Okay, so dQ is equal to 1/2 t to the 1/2 plus 0.2 dt integral. So Q at t, the charge at t is going to have to be t to the 3/2 divided by 3 plus 0.2 t plus some constant integration c. Alright, the capacitor has a voltage 100 volts across it. At a given time, the capacitor is connected across a source. Okay, so plus C. Alright, so now the issue is, what is Q at 0? That's what we have to figure out. Velocity, not velocity, but the voltage across the capacitor is Q over C, right? So Q at 0 is 100 volts times the capacitance 10 to the minus 4. Okay, so C, that constant C, 0, 0, 0 has to, which is different than this guy C because this is capacitance, is going to be 0.01. Okay, so Q at T is equal to T to the 3 halves over 3 plus 0.2t plus 0.01. What does the we want to find the voltage at 0.16. All right, so the voltage across the capacitor at times t is going to be the Q guy, t to the 3 halves over 3 plus 0.3 t plus 0.01 divided by the capacitance 0.0001 farads. Alright, so voltage across the capacitor at 0.16 equals 0.16 to the 3 halves divided by 3 plus 0.3 times 0.16 plus 0.101 divided by 0.0001. This is where a nice calculator would. The square root of 16 would be 0.4. 0.4 raised to the 3rd power would be 0.064 divided by 3 plus 0.048 plus 0.01 divided by 0.0001. Is it time to get our calculator out yet? 0.064 plus 0.064 divided by 3 plus 0.048 plus 0.01 equals divided by 0.0001. Boom. Now, do we expect some answer greater than or less than 100? You have a capacitor that's already has 100 volts across it. You start shoving in charge, you'd expect the voltage to go up, right? Yeah. So my calculator says the answer is 793 volts, which is probably the right answer. The right answer is in the back of the book. We could look at it, but we don't have time in case I have it wrong. Number 21. Quit looking at the back of the wrong. What's wrong with you, Joel? Number 21.
We gotta make sure.
No, we don't. The circuit, the current in a given circuit, I, is equal to T, the square root of T squared plus 1 amps. Find the charge in coulombs that passes a given point in the circuit after 1 second. Okay, so Q is 0, and T at T is equal to 0, and we want to find 1 second. Okay, so dq dt, what's the matter? Did I get it right? Good.
Well, you're close enough for government.
Well, it probably is because it's probably just a kind of digit thing. So I have dq is equal to t square root of t squared plus 1 dt, integrate both sides. Alright, so Q at times T is equal to, okay, this is where we guess. We're going to guess we're in the form T squared plus 1 to the 3 halves. G prime 3 halves T squared plus 1 to T. So I need a 3 here and I need a 1/3 out there. So this is going to be 1/3 T squared plus 1 to the 3 halves plus C, but C is 0 because our initial condition has Q at 0 being 0. Q at 1 second equals 1/3 1 squared plus 1 to the 3 halves. 2 to the 2 cubed is 8. The square root of 8 is 2, the square root of 2 over 3 coulombs. That's not, C is not the constant of integration. C is not the farads of the capacitor. C is now coulombs, isn't that? And C could be the speed of light too, as lowercase, but it's not the speed of light. Gentlemen, we have made it through the 2 sections required, so I guess it's time to go home. Turn in your test. For those that are in the robotics class, remember that we don't have robotics